So hey everyone, today we are going to discuss a problem and the name of the problem is print all primes till n. Okay, so what does the problem statement says? Problem statement says that you have to print all prime numbers between a range. Between a range means I'll explain it to you. So we just simply read out the problem first. So firstly we have to take an input which is low, and we have to take an input which is as a high. So and within that range, within that low and high, we need to find out the number which are prime. Okay, so what does it mean? It means that we have to take an input for low, we have to take an input for high, and just by including this number, we also have to include low as well as high. By including these numbers, we have to identify how many numbers in between these numbers are prime. In between these numbers are prime. How many numbers? It means which are the numbers which are prime. So okay, so if the number is prime, we need to print that number. Exactly, we didn't have to identify how many numbers. Exactly what we have to find out, which are the numbers which are prime. Like if the number is prime, we need to print that number. Okay, so for example, let me consider a test case where you have given a test case, like we have given a range for low, that is 10, and for high we have given a range that is equal to 17. So what does it mean? Till this, within this range, how many numbers are prime, we have to identify that. For example, in this range, that is the numbers come which are 11, number come that is 12, the number come which is 13, number come 14, number come that is 15, number comes that is 16. Okay, so 11, 12, 13. So in this range, how many numbers are prime? We can say 11 is prime, we can say 13 is prime, we can say 17, this is also prime. Okay, so this is the sole case, this is the sole thing which we have to do in this problem. Okay, so how we are going to do this, that let me discuss that first. So what we are going to do is, in this problem, what we'll do, we'll simply we just simply run a loop from low to high. For example, I'll consider that test case. For example, I'm just writing down all the values. For example, I'm writing down 12, 13, 14, 15, 16, 17. Okay, and I'll put my pointer at this. For example, my pointer name is I. I'll run a loop. I'll first run a loop from low to high. For example, I'll run a loop. I'll make it I. That is, I'll start from low, and I'll run my I less than till high, less than equals to high, and just I'll make it I plus plus. Okay, so here what I'm doing, I'm traversing this range, and within this range I'm going to find out how many numbers are prime. Okay, so for example, currently my pointer is at 10. I'll check whether this number is prime or not. So how I can identify that? Exactly what I'll do for that, I'll run a loop for that is from j equals to 2 to j runs till where it run till that is I, and here I'll make it j plus plus. So what does it mean? For example, currently I is holding 10, so I'll run a loop from 2 till 10, and here what I'm going to check, that I'm checking if my I value, that is my I is divided with any of the value. It means if it is divided with any of the value, any of the j value, and if it's complete, if it is a divisor of j, if my I value is a divisor, or it is having any multiple between the range of 2 till that number, I'm simply making it count plus plus, and I'll break that number. So what does it mean? I'm making counter plus plus, and I'll just break that number. What does it mean? It means, for example, in case of 2, in case of 10, what I'll do, I'll divide it by with j. I'll divide it with j. So here my j is what? J is initially 2. I'll divide it with 2. So when I'll divide it with 2, so j completely, it means 10 completely divided by 2. So if 10 is going to be completely divided by 2, then it's never be my prime number. Why it's never be my prime number? We all know the definition of prime. Prime number are those number which doesn't divided by any of the number except 1 and itself. So we can say, in general, we can say every number divided by 1 and itself. Okay, so we can say if we are getting any divisor for any of the number, if we are getting 1, 2, if we are getting exactly 1, exactly 2, exactly 3, or many more, if we are getting a single divisor except 1 and itself, except one and itself, if we are getting single divisor of a number, the number never be my prime number. Okay, so for this 10, we'll say that 2 is a divisor of 10, so my 10 will never be a prime number. Okay, so if it's not prime, I'll not print that 10. Okay, I'll increase my I value, so now my pointer will be at this position, and for this position I'll check the same condition. Okay, so for this I'll check that 11 is prime or not. I'll check out, I'll run a loop, so my control comes to this condition, and for this my I will be plus plus, and for this I'll check that I, that is 11, that is my 11 is a prime or not. So okay, so what I'll do, I'll run a loop from j equals to 2, j equals to 2 till j less than equals to 11, and I'll check if there any divisor exists between 2 to 11 which divides the 11 completely. So I can say there is not any divisor, there is not any number which divides the 11 completely, or we are not having any of the divisor between two, we are not having any of the divisor of 11 from 2 till 11. So if we are not having any of the divisor, then it means the number is prime number. So I am simply, if the, so my counter variable is not going to be increased in the whole process. If it is not going to be increased, I'll make it just I'm initializing count here equals to 0. Okay, so because I always have to make my counter 0 whenever it run in this condition, it reaches to this condition, the count must be 0. Okay, so if after this, if my count is 0 at the end of this condition, if my count is equals to 0, it means the number is prime number. So I'll simply print that number. So for this we again we'll if the number is prime, I'll just print that 11, and I'll make my counter, I'll make my pointer to I'll increase my I. So now my I is pointing toward 12. So I'll check that 12 is prime or not. So according to this, 2 is a multiple of 12, so my 12 is not a prime number, so I can say 12 is not. Now my I pointer increases to 13, so 13 is a prime, so I'll print 13. 14 is not prime, so my this condition will not run, so this condition will say that 14 is not a prime. So if 14 is not prime, I'll not print that number, because exactly what I have to done in the problem, I have to print only the numbers which are prime in the range. Okay, so I have given a low variable, I have given a high variable, and within this range I have to identify the numbers which are prime number. Okay, so 14 is not prime, I'll not print it. 15 is not prime, I'll not print it. 16 is not prime, I'll not print it. And in case 17, so 17 is prime, I'll print these three numbers. Okay, so this is the simple code. Can anyone guess the complexity for this approach? Let me help you. So in case of space complexity, we can say we are not using any extra space, so we can say big of 1, but so big of 1 is the extra space that we are using. So space complexity is big O of 1. Okay, so what about the time complexity? So time complexity is quite interesting. We can say our time complexity is what? Our time complexity is equals to what? We can say time complexity is equals to low. This is my range. So okay, so it means I am running this loop till low to high. So I can say I'm running this loop that is around high minus low. It's around high minus low number of times. Okay, so if I'm running this loop till then, and what about my this loop? So this loop runs, it's depend on the value. So we can say it's depend in case of the worst in the worst case, I can say it run till the max my j is that is here I have done a mistake. Just to improvise this approach, I'll make it j into j, because I'm using this thing. I have already teaches you that is I'm using a square root condition, because I am running a loop till square root of n. So that's why I'm using j into j, that is less than equals to y. Okay, because as this thing I have already tell you in the previous approach, previous question, is a number prime or not. So you can read out that I explained that thing in detail there, so you can check out that. So it run till high minus low into, that is what, the maximum, that is the maximum of this range. So maximum currently my maximum is, that is 17, so square root of 17. So this will be the whole complexity of my solution. Okay, so because we can say that is high minus low, and for each of the high minus low I'm for example, if I'm considering it as a t, I just make it as equals to t, and I'm just running this t every time, and for each t I'm identifying my number is prime or not. Okay, so that's why this number will be square root of that's it's depend on that low range. So I can say max it run till the maximum of this value. Okay, so I hope you got the solution. So let me go move toward the code part. What we are doing in the code part, firstly we are taking an input for low. Okay, so firstly we are taking an input for low. What we can do for low, I'll just use a scanner dot next, and here what we'll do, we'll make end simple with this one. I'll take input for high as well as, and after taking the input for high, I'll just make it high. After making the input for high, what I'll do, I'll run a loop for int I equals to till low till less than equals to high. Okay, and for this I'll make it I plus plus, and here I'll make my counter variable which will count how many numbers are exactly divisor of that number. Okay, and for checking that, I'll run a loop for int j equals to 2 to j into j. So it's for the optimized part. So j into j, that is j into j less than equals to I, and here I'm making j plus plus. And what I'm doing here, if my I divides by j completely, it means it is a divisor, I'll make my count plus plus. So again, here what I'll do, I'll simply, if my counter is increasing, if it's increasing my counter, I'm just going to break this condition, because if it is divided by any of the single number, then it's the number never be a prime number. Okay, so I'm using that thing, and here if I'll check if my counter is equals to 0, it means my number is prime number. So I am just using that. That's thing, and here we need to print what the number is prime or not. So we need to print the value. Okay, so I'll print the value, that is I, because my number is I. So I hope everything is fine. Let's submit that. So you can say that it's got submitted. I hope you like the solution. If you like the solution, please hit the like button. Thanks to all. Thanks for watching the video. Please hit the like button. Thanks everyone.